Hey everyone, all of you should already be familiar with the humble odometer.
A device that uses the rotation of a car's wheels to figure out how far you've driven.
Simple enough with wheels touching the ground. But what if you're in the air?
Fortunately for us, we still know the plane's speed. Let's say that in this situation,
the speed at a given time is represented by the following function. We already know that with constant speeds, it's possible to tell the distance from the time traveled. For example, traveling 50 miles per hour for half an hour means you travel 25 miles. What we'll do with our function is now split it into equally sized x value sections where the speed is constant. For now, we'll be taking that constant from the center of our x section. Now to find our approximation of the distance traveled, we merely find the total area of each of the rectangles that we now have.
Notice how having more rectangles makes our approximation more accurate. This is because the difference, on average, between the actual speed and the estimated speed is less. Cool thing is, we can represent this mathematically as well.
Let's start with an individual rectangle. Here, I represents the individual rectangle, so we can represent its height as f of x at I. To get the width, we need to find the change in x, or delta x. Since we know the total domain and the amount of rectangles being used, we can just use the domain over the amount of rectangles, n. For the mathematical representation of adding all said rectangles together, we simply use sigma notation, which represents the sum of n rectangles.
Now we have a way of manually computing the area of functions, such as our plane distance. But what if we want to be more accurate? Heck, better than that. Infinitely accurate. As with most things dealing with infinites, we have to use a little bit of calculus. In this case, a limit. As the number of rectangles, n, approaches infinity. This is just an integral, or rather, an integral is an infinite Riemann sum. Pretty cool, huh? Thanks for watching.